Alrighty, let's take a look at the second lesson here in chapter 7. This is going to be an application of those exponential equations. We're going to be talking about like growth, compound growth, decay. But first we're going to just talk about like how do you calculate growth in a situation, not a graph. This is still going to be my start value. How much did I have initially? 1 plus r is representing, the 1 is like what you had because it's basically representing 100% of what you started with. And when you move it over 2 decimal places, you get a 1. Then you're adding the rate of increase. And it's going to be increase in this situation because we're growth. So if you have to add an interest rate onto something or a rate of growth onto something, keeping in mind that whatever that rate is, you take it from a percent. So for example, 10% is going to actually just be 0.10 when you go to do R because you move it over twice. So if you have 3%, you're going to be putting 0.03 because you move it over twice and you got to fill that spot. It gets confusing when it's like 2.5% that's given as the growth. Then you still move it over 2 places, so you would use an R of 0.025. So just kind of keep that in mind. That is true for decay as well, but here instead of adding to what you had, you are reducing or subtracting. And so these together become that base, because you can see that's the thing that's raised to the power in both scenarios. So the 1 minus r and the 1 plus r become that b value that gets raised to a power. And so that's going to be, what is going to turn out to be greater than 1 or less than 1. So I'll show you what I mean. So population of the U.S. in 2021 was 331.9 million. That's going to be my starting amount. Keeping in mind that I'm starting in 2021, so that's time 0. Annual growth rate is 0.7. So this is a good example. That's a percent. So I still have to scoot it over 2. So my R is actually going to be 0.007 when I go to do the problem, because that was given as a percent, meaning out of 100. Write a model or equation to represent the growth. Okay, well, it's growth because it's increasing. So you're saying, okay, the population is 331.9 million. And then I'm going to have the population that I had plus 0.007 for T years. So if you put that all together and made it one B value, it would be that the population is 331.9 growing at 1.007 for T years. I don't know if anybody really cares if you do that ahead of time, like put the 2 numbers together or not. Now you're going to predict the population in 2029. Well, if your original time was 2021, you would find T by saying 2029 minus my start time of 2021 is 8 years. So I'm just going to put that in and say the population is 331.9 times 1.007. Notice that that B value is greater than 1, which is why it's growth, because I added to the 1. And now this is going to be an 8. And I am putting that directly into my calculator. 331.9, parentheses 1.007, parentheses raised to the 8. And I am getting 350.95. And then keep in mind that that is million. So that is going to be my answer. And my sister's calling me, so let me text her and tell her that I'm making a math video. Okay, so a new example. A new jet ski costs $12,000. That's the starting amount. It is decreasing in value by 10%. So if I move that decimal over, that's going to give me an R of 0.10. Write an exponential decay model of the value after T years. So my value is going to be that initial value, but now I'm going to do 1 minus 0.10 to the T because I'm taking value away. It's decreasing. So if you actually did 1 minus 0.10, you'd be at 0.9, and that's less than 1. And so that's why this is a decay or a decrease. So here is my value equation. Here it says, what's the value after 3 years? Well, then time is 3. And so my value will be 12,000.90 to the 3 power. So if I do that on my calculator, I'm ending up with a value of $8,748, sorry about that, dollars. And then think about whether your answer makes any sense, because this is decreasing in value. So does it make sense that it started at 12,000 and is now down to 8,000, whereas here my population grew to be bigger than it used to be? So you want to kind of look at your answer and see if it makes sense. So those two equations that we just talked about right here and here, that's for growth and decay when it doesn't say the word compound. Compound interest is a different thing, and it's typically revolves around money. So like if you get a credit card and then you buy something for $100, but you have an 18% interest rate, by next month now you owe them 118. But once you owe them 118, now they compound your interest, and now you got to pay 18% of that. So now you owe them $139.24 for the same $100 item. It compounds, like you start paying interest on your interest. It can work in your favor, like in a savings account. If you put $100 in, your savings account earns you maybe 2% if it's a good one. Now you have $102. But the next time they calculate the 2%, they're calculating it off of 102. So you make $2.04. So you start making interest on your interest, and it compounds, it grows on itself. The key is that when you're doing the problem, it has to say compound, and it'll tell you that word has to be in there. And let's just break apart this formula. So if you see the word compound, you know you're going to be using this formula. All right, so A is going to be the ending amount. Like, what do you have at the end? P is going to be your principal, which is just like a specific term for money, but it's still your start amount. Because this is just like a big fat version of what we were doing, A1 plus R to the T. So the thing at the end is the ending amount. So that was like this. This is in the same spot, and that's your start money. And then R is still the same as it was before, your rate, and you'll still have to change it from a percent down to a decimal by moving that 2 spots to the left. T is still time in years. So the really, really new thing is this N. And you're going to notice that the N is down here and then also in the power. So you're going to use the same number in both spots. And the N is the number of times compounded. So how many times are they adding that interest on top of the interest per year? So you have to think about words, because if it says it's compounded monthly, then that's going to mean you have 12 compoundings per year. So that's the 12 would get into the equation. If it's compounded semi-annually, I never know if there's 1 or 2 N's, so we're just going to pretend I'm doing it right. That would be twice a year, so that would be 2. And so you just have to think like, okay, it is compounded quarterly. How many quarters are there in a year? That would be 4 times a year. So the N is the thing you have to think about. How many times is it compounded? So it says you deposited $5,000. That's my principal. I started with that. Here's my rate, but I'm going to use 0.04 because I got to scoot that decimal over. Find the balance after 6 years. That's my time. If it's compounded annually, I guess there's 2 N's, oops, is going to be once a year. So I set this up. My principal was 5,000. I have 1, which is representing the money I had, plus, and then if I'm looking at my formula, I have my rate of 4% changed to a decimal over 1, which I guess I don't really have to write it, but I'm just showing you the formula. And then 1 times 6, because that was my time. So this one, the 1 isn't really important because anything over 1 is just itself. But practice typing it in exactly like this. And if you have a calculator that's a little older, and you have to use the little arrow button to do the power, make sure that you put parentheses around the 1 times 6 so it knows the whole thing is in the power. So you're going to type literally the whole thing in. 5,000 parenthesis 1 plus 0.04 divided by 1 parenthesis raised to the 1.6 power. And at the end of that 6 years, my $5,000 will have turned into $6,326.60 if I round off. Fantabulous. What if, and these are going to be all really similar, the thing they're changing is the compounding, because you're still putting in the same 5,000 as your principal. You still have a 4% rate, and you're still keeping it in there for 6 years, but compounded quarterly means your N would be 4 times a year. So here and up here, I have a 4. So instead of just compounding it 1 time a year, I'm going to compound it 4 times a year. So practice putting that into your calculator. Here I'm getting $6,348.67. So a little more money because they compounded it a little more frequently. Here we go again. 5,000 is my principal. This one's demonstrating that the money will change as you compound it more frequently. Still 4%. And the time is still 6 years. So the only thing that I'm filling in is the N here and here, because remember those are always the same because they're the same in the formula. And it says compounded monthly. How many times is monthly a year? 12. So a 12 goes here, here, those get multiplied, put them in parentheses, and put it into my calculator. And I'm getting, drum roll, $6,353.71. So a little bit more because it got compounded a little bit more. All right, grand finale. I'm going to deposit $5,000. No way. So same principal amount, 4% still. So watch, that'll normally change, but they're just showing that the compounding is changing each time. Now it's compounded daily. How many times a year is that? 365. We're not going to get picky about leap years. But that N will then go here and here, and then my time is still 6. So now this goes into my calculator. And you would think this would get like giantly bigger, but it honestly doesn't get significantly bigger at this point. And so make sure that whole 365 times 6 is up in the power. And I am getting 6,356.16. So it did get a little bit bigger, but it's only like $3 bigger than when they were doing it monthly. Okay, so you have 3 key formulas here, and this one is only used if you see the word compound interest. If it's just talking about growth or decay, you're going to go back and use these 2 formulas depending on your situation. Hope that helps. Bye.